Hello students, welcome to Unit 5 Notes, Section 7.5. This follows our 7.3 notes. For this warm-up, I will explain it. Feel free to pause it and write everything down if you need to. What I needed to do was compare each of these similar triangles. So in this case, I had to, for number 1, I had to find out what this side was because I'm looking at my top triangle here. So I did 84. I know the whole thing is 84. This might be, I don't know, 44, but the only way to do that would be to take away this part that I know. In this case, it's a variable, so it's unknown, but I know it in terms of variable. So 84, take away this piece right here would give me that. So if this whole thing was 84 and this was 40, that would leave me with 44 up top. So then I combine this one because I'm trying to compare the left side of the small triangle to the left side of the larger triangle as I compare right side of my small to the right side of my entire large triangle. So I set that up as 84 minus x over 84. So part over, well, smaller over the whole, 30 over 45. And I did all the algebra out and I got 28. This next one, again, I did base of the small one to the base of the large one, which was 4 to 11. And then I did x and x plus 6. I couldn't do x and then 6 because it's not the whole triangle. That's just a portion of your triangle. So setting that up and doing out all the algebra, we end up with 24/7. This next one, again, the small triangle and the large and the base and the base. The large triangle is an x. It's 7 plus x. So combining that together, do out all the algebra, you end up getting 9.8. And then this last one is 7.5 is to x, as 6 is to 9. And I set that one up solved and get 11.25. So again, feel free to pause and then you can write it all down and then you can continue on. So we're going to talk about proportions in triangles. And actually, sometimes there's an easier way to set it up. Sometimes you can use just the x or you can use just this x, but I'll show you when you can and cannot use it. You can use it when they're splitting sides. So this theorem today in proportions in triangles, we're going to be using the side splitter theorem. Okay, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. So what we are going to eventually get to today here, we're going to let's draw the triangle here. And I will let's say that this was parallel to this. We can say A is to B as C is to D. Only when the sides are split, which here they are, these two sides are split. What you can't do is you can't do bases. So I can't say A is to B as 3 is to 4. Like these bases don't work. It has to be A and B and C and D on your left and on your right. Which also you can do it multiple times. So if I draw in another line, let's say I draw in another line, and that were to be extended, and I throw on a parallel, F and G I can add. I can say A is to B as C is to D, but I can also say B is to F as D is to G. Or I can say AB, A is to F as C is to G. Okay, so these parts are all, you can interchange them as long as this is parallel and we keep splitting our sides. Again, what you can't use S and T. We cannot use bases. Okay, so we're not using the base of our triangle. Wait, we cannot use bases with side splitter. That's all. Okay, let's do some problems involving it. We have, and are we doing angle bisector? Oh, we are doing the angle bisector theorem. So the first part today, proportions in triangles, we'll use a side splitter theorem, and then we'll get into the triangle angle bisector theorem. All right, so this first one, before we would have done this part, we would have done this is to all of this as this is to all of this. We no longer have to do that because we know that these sides are parallel. So I know they're parallel because these are both right angles right here, meaning that they would have to be parallel. So I'm going to set that up and say x plus 1.5 is to x as 5 is to 2.5. And I'm going to cross product. I'll get 5x. I'll get 2.5 x. And then, let's see, 1.5 times 2.5. Yep, that's 3.75. I'm going to take 2.5 x away. And then divide both sides by 2.5. And I get x equals 1.5. There we go. And we are done. All right. And again, we can do it for this one. We'll just do x over 16 equals 5 over 10. And we're going to find the cross products. So 10x equals 80. Divide both sides by 10. And x equals 8. All right, and this one makes sense. If this length is 5 and this length is 10, that's double. 8 doubled would be 16. So together this is 5 and 15 and 8 and 24. All right, here's a couple more. 8 is to 10 as 6 is to x. Oops, find the cross products. So 8x equals 60. Divide both sides by 8. So 7 and 60 divided by 8 is 7.5. All right. The next one, we will do x plus 4 over 2x. And again, remember, before this lesson, you would have had to add these together. and add these together. But now, because we have parallel lines, the side splitter allows us to always set it up this way, where we're working with the split sides, 9 and 12, and we will find the cross products. So 12x, 12 times x plus 4 equals 18x. So 12x plus 48 distribute equals 18x. Take away 12x from both sides. 48 equals 6x divided by 6. 6 times 8 is 48, so x equals 8. And it makes sense. 9 over 12 equals 16, and 8 and 4 is 12. So yeah, 3, 6, 9, 12, 4, 8, 12, 16. So I did that one right. And we have our last one. X over 13 minus x equals 2 over 3. It's going to give me 26 minus 2x. I distributed equals 3x. You know what? I'll show the distributive property actually happening. So 2 times 13 minus x equals 3x. And then we do the distributive property. And now add 2x and add 2x. 26 equals 5x divided by 5. X equals 5.2. 5.2. Okay. And we can check this. 2/3. 2 divided by 3 is about, uh, 0.667 repeated. And then we're going to have 13 minus 5.2 is 7.8. So 5.2 divided by 7.8 is 2/3 as well. So these are equivalent, meaning that 5.2 works out. That would be 5.2, the whole thing, 13 minus 5.2 is 7.8, so plus 5.2. The whole length is 13. 5.2 is 2/3 of it. Good, good. All right, here we have a real world application. Sale making. Sale makers sometimes use a computer to create a pattern for a sale. After they cut out the panels of the sale, they sew them together to form the sale. So all these items are parallel. These are all, they're not triangle. Well, this is a triangle. This is a triangle. This is a triangle. This is a triangle. Okay, and this is a separate triangle, but that doesn't follow the same pattern because it's not, this item is not parallel. But we can solve for x and y, because what we're going to do is we're going to say 2 is to x as 1.7 is to 1.7. Well, in that case, x will have to be 2, but here, let's set it up. 2 is to x as 1.7 is to 1.7. This is pretty much going to get me 1.7x equals 3.4. And then divided by 1.7, we'll get x equals 2. I mean, that just follows the pattern. Okay, and the next one is solving for y. So I can do the same thing. I could do, I can actually do 2:3 as, so I'm taking 2:3 as 1.7 is to y. So I'm going to get 2y equals 7, 14, 21, 5.1. Let me just make sure 5.1. 1.7 times 3 is 5.1 divided by 2. Yep. Y equals 2.55. All right. There we go. Those are the lengths of our sail. Now I'm going to do one here. We are going to use 15/26 for both. So use 15/26 equals 16.5 over y. And I'm also going to set up another one, 15/26 equals x over 30. I'm just going to solve both of these. Let me erase those. All right. Solve both of these. 15y equals, let's see, 26 times 16.5 is 429 divided by 15. Y is equal to 28.6. Now we have 26x equals 450. So 30 times 15 is 450 divided by 26. Wait a minute. Yeah, 450 divided by 26. X approximately equals 17.3. Yep, 17.3. I could, if I leave it as a fraction, let me find some factors here. It would be 225 thirteenths. So let's just round it to 17.3. All right. It makes sense to take a look here. 15. We have 15 and we have 16.5 is a little bit greater than 15. So 26, what's a little bit greater than 26? Well, that is 28.6. So that makes sense. And then look at that, 28.6. Greater than that is 30. So greater than 16.5, which is 17.3. So that part makes sense as well. All right, that's the first part of our lesson. And now we're going to do the triangle angle bisector theorem. This one is these triangles. I want to be clear. This triangle on the right and this triangle on the left are not in any way similar. We're not talking about similarity anymore. This had to deal with similarity and proportionality. This has to do with the triangle angle bisector theorem. So if angles are bisected, so if a ray bisects an angle of a triangle, or in this case, a line segment, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So no matter what, 5 is in ratio with 8, and 6 is in ratio with x. Okay, so it says, then it divides the opposite side into two segments that are proportional, so 5 and 8, and x and 6. So what I can do is find the value of x. I'm going to say, for this one, I think I'm on purple, yep. I'm going to say 5 is to 8. I always go smaller to larger. 5 is to 8 as 6 is to x. So you notice what I'm doing? I'm going from the right to the left to the right to the left. And I'm going to find the cross products. So 5x, 6 times 8 is 48, divided by 5. And I'm going to get x equals 9.6, I think. 9.6. 48 divided by 5 is 9.6. And that's it for the triangle angle bisector theorem. Not too bad. You just, the only thing I see students mess up is the order to which they do this. Some do 5 is to 6 as 8 is to x. You'll notice you will get the same thing, but I really think you should go from the side that split is proportional. So I go 5 to 8, then 6 to x. Some students go 5 to 8 to x to 6, and these are flipped, and they get the incorrect answer. So that's the only error I really see them making. All right, so I'll do 3.6 to y as 5 is to 8. And I'm going to get 5y. And 3.6 times 8 is 28.8. And so y, whoops. So y is equal to 5.76. 5.76, okay. And then here's our last slide before we start the notes part. So we're just going to look and fill in the blank. So here we have, I have the ability of writing, so we have RS is to something as JR is to KJ. So we used KJ, we used JR, we're using RS, so we have to use KS, but it has to go in the same way as KJ, so we'll say KS for this one. So let me erase that. Yep, so we did RS is to KS as JR is to KJ. They go a little bit out of order, but that's all right. We'll just try to stick with the order. Yep. So KJ, now they have KJ. Wait, we already used that color. Okay, so we should be using this one, KS. All right, we have KJ. We have this part. We have JP. We have KS, so SQ is the only one. That would make sense. All right, QL. Where's QL? QL, PM, SQ, and so it would have to be JP. JP is what would match in this case. Now we have PT. We have PT. and I don't know, but I have TQ and I have KQ. So I have TQ and KQ and PT, and it will have to be KP. All right, this one, KLLW. We have KLLW, and it would have to be something and MW, which would be KM. All right, we have LQKQ. Let's see, LQ and KQ and KP, and we'll have to do MP. And next one, JKKS, JKKS, and then it's SQ, so it would have to be JP. The last one, KL and KM, so it's KL and KM, and this is MW, and this should be LW. All right, and that finishes all of our notes, and we'll do this in class. All right, good luck on your IXLs and taking these notes.